Hello, this is question 3 on your November 2020 paper 1 from OCR, the AS paper, the year 12. So you have to solve this equation. And I think every time you have sine square and tan square. So my inclination would be always to write this tan as sine divided by cos and carry on from there. So we will have 4 sine squared theta is going to be sine square theta divided by cos square theta. We can multiply everything by cos square and we'll have 4 sine square theta cos square theta equals sine square theta. And I know it's quite tempting to just cancel these two, but you cannot ignore that when sine theta is 0, this equation is true. So you cannot cancel a variable without thinking if that variable can be 0, and that's the case here, yeah? So we are not really canceling. What we are doing is, if you want to think that way, factorizing. So we have 4 sine square multiplying 4 cos square theta minus 1 equals 0, yeah? So we are taking this to the side and factorizing. That way, I think it's easier for you to see, because this means that this can be 0 or this can be 0. So I have to set of solution sine square equals 0 and 4 cos square theta minus 1 equals 0. This one, sine square theta 0, means sine theta 0, and my interval is 0, 180. So I know sine theta is 0 when theta is 0, and the next time is when theta is 180, which is again in the interval, yeah? Again in the interval. And the next one, this branch of solutions would say that cos square theta can be 1/4, which means cos theta could be 1/2, or cos theta could be minus 1/2. Don't forget the negative answer, because when I do the square root of this value, I can have the positive or the negative. Cos theta 1/2, when you do cos minus 1, you have theta is 60 degrees. When you do cos minus 1 of minus 1/2, you get theta 120 degrees. And you don't have any more answers in this interval, which is quite a small interval, yeah? So your answers, theta is going to be 0 degrees, 60 degrees, 180 degrees, and 120 and 180. So this, and this, yeah? And then the second part is simpler. So I say prove that this expression can be written this way. So when you have an identity, the 3 lines, remember you cannot move things around. So you cannot move things from right to left. You are going to work with one of the sides until you are able to write it as the other side, yeah? And you can start with either, but in this case, we cannot do much with this one. So we are going to start with this one and see if we are able to write it as cos theta. You know sine square is 1 minus cos squared, yeah? What means that if we substitute sine square as 1 minus cos squared, we will have 1 minus cos squared minus 1, and we are going to be able to cancel something. So let's going to start with that. So for B, I'm going to do it in another page. For B, I have sine square minus 1. I'm going to start with the left-hand side, plus cos, divided by 1 minus cos. And I want to have at the end only cos, yeah? So 1 minus cos. And I'm going to write sine squared as 1 minus cos squared, just using the identity that 1 squared plus cos squared is 1. So I just substitute this sine squared by 1 minus cos squared, divided by 1 minus cos. I can cancel this one with this minus 1, and I have cos square and a cos. I can factorize this expression and write as cos theta minus cos theta plus 1, or if you want, the other way around, because it looks better. So the minus after 1 minus cos theta. 1 minus cos theta divided by 1 minus cos theta. And then you have it, because you can cancel this factor, this denominator, and this is cos theta. Yeah, and that's the right hand side. We started with the left hand side. Yeah, and that's all with this question. You have proof this bit here. Yeah.